Hi, I'm Dave Baring, Technical Director here at TriStar, and welcome to another Tech Talk. We get a lot of questions about, what's the most logical way to make a part, whether we should injection mold that part, whether we should machine it, and it really comes down to a couple of basic questions that we need to ask you as a customer. The first and the most obvious question is, what's the quantity? Obviously, with injection molding, you've got some capital expense up front, and that's for the tooling. And tooling nowadays can run anywhere from the low thousands, $3,000–$4,000, and very sophisticated tools can run into the tens of thousands of dollars. So if the quantity justifies the tooling, injection molding is always a good first look. But then there's some further questions that we need to ask to be sure that injection molding will actually work. One of the first things you need to ask is tolerances. Are the tolerances matched with the material? And are they tolerances that can be held with that particular material through injection molding? There are some materials that you can't hold better than a couple of thousandths. There are other materials where you could hold tenths with a really good tool and a really good machine. So tolerance is kind of a critical question right up front after the volumes. The next thing we want to find out is what's the geometry of the part. Sometimes parts can be a little bit too complex to injection mold, believe it or not. And that complexity usually comes from either a combination of wall thicknesses. You may have one part of one section of the part is say 100 thousandths thick wall, and another part is 40 thousandths thick. That's a very complicated part to mold. So we need to look at the geometry of the part. Also, depending on how the tooling is going to be designed, are there any draft concerns? How is the part going to be molded so the parting line settles in at the right place in the part? Sometimes flow and parting lines can become a big issue with the structural integrity of that part. Next thing is stresses. Injection molding does produce certain stresses, and especially if you have fillers in the resin, there can be stresses from glass flow or carbon fiber flow, and these things need to be taken into consideration right along with the geometry and the tolerances. Surface requirements of the part. You can get very highly polished tools, so you can get very smooth, shiny, nice appearing parts. But the more you do that to the tool, the more time you spend polishing out that tool, the more expensive it is. So our question is, what are your surface finish requirements on the part, both externally and internally? There may be some very small parts, for instance, that can be injection molded. But if you have very small IDs or ports that need to be molded, the question is going to be, how critical is that surface on the ID? And that's especially true in the medical side of the business. Some of these ports and tubes and things are very critical to flow rates for medication delivery, for instance. When it comes to machining parts, the big advantage of machining a part over molding is, first, it's more cost effective if your quantities are going to be under, say, 5,000 parts a year. Machining is generally a more cost effective way to do it. Now, that being said, it also depends on whether the material that you're wanting to use is available in a stock shape that can be machined. There are limitations there. Especially when you start looking at fills like glass fibers and carbon fibers, the percentages, and then sometimes you'll want to put lubricious additives in there like PTFE or silicone. Those are not readily available in stock shape, so machining versus molding will also come right down to what material you want to use. But when it comes to machining, there's a lot more flexibility, especially if you're talking about small runs. 1,000, 2,000 parts. It allows us to make the right machine selection to do the part the most cost-effective way. Also allows us to search out for better sourcing on the material, the raw material. But the other thing it does is that when you're machining parts, obviously if you need to make a change somewhere along the line, it's a lot easier to make a change on a machine part than it is on a molded part. So if you're looking at injection molding right out of the box on a design, remember that it's very expensive to go back and make changes along the way, especially if you have to add material to the tool and then go back and machine it out. It's a lot easier to take away material, but if you make a mistake and need to make a change and add material, it gets a little pricey. So molded versus machined, it's certainly something you want to take a close look at. Think about these parameters, and we'll help kind of walk you through that process and see what makes sense for you. Cost is always the issue, obviously, when you're looking at plastic parts, molded versus machined, but if you can justify the tool, you're certainly going to save money on the part cost if you injection mold. Think about us next time you have a question about molding or machining. TriStar specializes in those two areas, and we're certainly available to help you and talk you through tooling issues. So give us a call, visit us on our website. Again, we have an active blog site. We have Ask the Experts. There's a lot of different ways that you can communicate with us at TriStar, and our engineering department is certainly ready to help out whenever you need us. Thanks for joining us, and I look forward to seeing you again.